Hello and welcome to R.4. Today we are just introducing polynomials, adding them, subtracting them, and multiplying them. Next class will be all practice on how to divide them. All right, so it says a polynomial in one variable is an algebraic expression of the form, for example, 3x to the fifth plus 4x to the fourth minus x to the third plus 5x squared plus 7x minus 2. So poly just means many. Terms, oh, sorry, I'm jumping ahead. This has many terms, okay? A term is separated by addition and subtraction, and the polynomial is arranged with exponents in descending order. So this is an exponent with 6 terms. If I was going to split them by term, I would put the line right in front of, the addition or subtraction. This is a positive 3x to the fifth, positive 4x to the fourth, negative 1x to the third, positive 5x squared, positive 7x, negative 2, okay? It must have its exponents in descending order if it's in standard form. It's okay if you jump all the way to from 5 to 1. That's fine. It just has to, the 5 has to be in front of the 1. Here, the 10 is bigger than the 2, but the important thing is that the 3 is bigger than the understood 1 as an exponent, okay? So standard form, they're in descending order. Terms are just the expressions separated by addition and subtraction. So some of the terms are 3x to the fifth, 4x to the fourth, negative x to the third, etc. Those are all terms. The coefficients then are the numbers in front of the variable. 3, 4, and negative 1 would be the coefficients of those 3 numbers, or those 3, the coefficients of those 3 terms. Something else I forgot. In one variable just means that there's only an x, there's not a y. There's only one there's only one letter to replace the numbers. The constant is the number without any variable. So the constant for this polynomial is a negative 2. The leading term is the first term of the polynomial in standard form. It's the entire term. So the leading term of this polynomial is 3x to the fifth. The degree is the largest exponent of the leading term. Or sorry, the largest exponent, the term with the largest exponent, that is the degree. So this is a polynomial of degree 5 because the x is raised to the 5th power, okay? It's in standard form because x to the 5th is the highest exponent, and then the degree is the largest exponent as well. Note that if you had 6x y to the third, that is going to be a degree. What do you think? We said that 3x to the fifth is degree 5. Okay. 6xy to the third is actually a degree 4 polynomial because we take that y to the third and that's x to the understood 1. We can't combine them, but when we're talking about the degree, we do combine them and say that that's a degree 4 because we have 3 y's and 1 x. So it counts all the variables. For a polynomial expression, exponents cannot be negative. So if I had 3x to the negative 5th plus 4x to the 4th, this is not a polynomial. Okay, because the exponent is negative. If I had an exponent that was a fraction, 3x to the 1/3 plus 4x to the 4th. Not only are neither of these in standard form anymore, they're also not polynomials. This cannot be a fraction. This cannot be a negative number. It can be 0, right? 7x, in this case, x is to the 1, right? 5x squared. And then if you think about it, 2 is being multiplied by x to the power of 0 because anything to the power of 0 is 1. 1 times 2 is 2, or 1 times -2 is -2. Okay, so you can have a power of 0, you can have a power of 1, you cannot have a fraction, and you cannot have a negative number. Okay, also, when you have a polynomial 3/4 x to the third plus 7x squared minus 10x. This one's still a polynomial. It's okay if your coefficients are fractions, but there can be no fractions with a variable in the denominator. Okay, so again, this one's not a polynomial because the x is negative. This one's also not a polynomial. Should have made those the same color. That one is a polynomial. I'm going to give you another example of not a polynomial, okay? Not. This one's okay. Yes. No. If it was 3/4x plus 7x squared minus 10x, not a polynomial, okay? 1/x squared plus 3x, not a polynomial, okay? If you have your variable in the denominator, not a polynomial. Let's talk about what the leading term is and what the degree is for each of these examples. First thing you want to do is make sure it's in standard form. Here we have -6x to the third plus 3x squared minus 4x plus 1. It's in standard form. Our leading term is going to be -6x to the third. The degree is a degree 3 because the x is raised to the power of 3 and there's no other exponent, or sorry, no other variable raised to any degree. The constant for this is going to be the number 1. Good? The degree we found here, and the leading term is here if it's in standard form and does include the negative, of course, okay? The leading term here is a 4x squared, the degree is a 2, and the constant's a -3. Here it's not in standard form, so I'm going to rewrite it. X squared minus 2x plus 9. Note that the negative stayed with the 2x. Leading term is x squared, degree is a 2, and the constant's a +9. Good? Here we have 5x plus the square root of 2, so our leading term is 5x. Our degree is just a 1, understood 1 right there. And our constant is the square root of 2, okay? You might have these are called binomials because there's 2 numbers. You'll see trinomials. And then I'll use the word monomial. A monomial just means you have one term in your polynomial. Your leading term is 3x, your degree is 1, you don't have a constant. All right, adding polynomials. To add polynomials, just collect like terms. This and means plus. This is also plus. I could ignore the parentheses because they're not telling us anything we need to distribute through the parentheses, okay? So you can ignore them if it's addition. If it's subtraction, you cannot ignore them. All right, so all we're doing is collecting like terms. 7x to the third can be combined with -3x to the third. -x squared can be combined with 2x squared. 5x can be combined with 2x. So what you'll have is 7x to the third oops, minus 3x to the third. But in front of that, you'll have 4x to the fourth. And then you'll have negative x squared plus 2x squared. Then you'll have 5x plus 2x minus 1. When you simplify that, 4x to the fourth, 7 minus 3 is 4x to the third, negative 1 plus 2 is plus 1x squared, 7x minus 1. Good. Same thing down here, 3x to the fifth plus x to the third and 2x to the third plus negative 4x squared minus 5x squared plus 6x minus 2x plus negative 3 plus 1. Good. 3x to the fifth, 3x to the third, minus 9x squared, 4x minus 2. Now subtracting. So the first thing you want to do when you're subtracting is imagine that this is a negative 1. Okay, so you're taking that entire second polynomial and you're multiplying by a negative 1. Or you can also look at it as changing the sign of each term of the second polynomial. Okay, so I'm either multiplying by negative 1 or I'm just taking that positive 3, changing it to a negative 3. Negative 9 becomes positive, negative 5 becomes positive, and 3 becomes negative. Good. All right, I'll come down here. So for A, we had 4x to the fourth minus 5x cubed plus 7x squared minus 2. Now I'm going to take all of those, change the sign. So negative 1 times a positive 3 becomes negative 3x to the fourth. Negative 1 times a negative 9 becomes a positive 9x squared. Negative 1 times negative 5 becomes positive 5x. Negative 1 times a positive 3 becomes minus 3. So I multiplied by negative 1 or I changed the sign. Positive, positive, negative. Now, same thing as we did before, put it in order. So that becomes 4x to the fourth minus 3x to the fourth minus 5x to the third plus 7x squared minus 5x minus 2 minus 3. I already wrote that wrong because I was looking at the wrong one. Plus 5x. Combine those two. Those two. Those two. Good. So 4 minus 3 is just 1. I ignore the 1 and just put the letter. Minus 5x to the third. 7 minus 9 is going to be negative 2. Minus 2 minus 3. So we're just combining them. 2 and 3 is 5. And they were both negative. So it's a negative 5. I did something wrong. Thanks. Thank you. That's a 16. All right. Plus 5x minus 5. Any other mistakes you guys see? Good job. Thank you. All right. And letter B. 3x to the third minus 5x squared minus 8. Now again, this pen's already dead. I don't know why I always pick it up. That positive 3x to the fourth is going to be multiplied by a negative 1, so it's going to be minus 3x to the fourth. You're going to take a negative 1 and multiply it by the negative 7, so I'm going to get a positive 7x to the third. Negative times a positive is a negative 5x. Negative times a negative 1 gives me a positive 1. So that has been distributed. We distributed that negative to the 3, the negative 7, the positive 5, and the negative 1. Now we can combine, put it in order. Negative 3x to the fourth is what I'm starting with because it's the biggest exponent. Does that look okay? Now I can combine the 3 and the 7 and the negative 8 and positive 1. So 3 and 7 are both positive, so that's 11 x to the third. Negative 8 plus 1, so 8 minus 1 is 7, but the 8 is a negative, so it's a negative 7. No, 7, 8, 9, 10. Two mistakes. All right, just also to be clear, let me give you an example of like terms, right? 2x squared plus 5x squared is 7x squared. But if I had like 2x squared y plus 5x squared, I cannot simplify that because that one has a y. So they have to have the same exponents raised to the same powers to actually be like terms. Unlike. And these are like. Good. All right. I added on an example because I want to make sure that you understand how to distribute a single term through the parentheses. So what this means when we have 8 times outside the parentheses is we're taking 8 and we're multiplying it by the quantity 4y squared minus 5y plus 7. We're taking negative 7, and just like we did negative 1, negative 7 times 8, negative 7 times a negative 9y squared. Okay? So now we have 8 times 4y squared plus 8 times negative 5y, and you're welcome to say that that's minus 8 times 5y, plus 8 times 7, minus, plus negative 7 times 8. As you can see, there's a lot of ways to do it. So you could just say minus 7 times 8, plus negative 7 times negative 9y squared. Good? Eight times 4 is 32y squared. 8 times a negative 5y is a negative 40y. 8 times 7, 56. Negative 7 times 8, same number but negative, negative 56. Negative 7 times negative 9, and negative times a negative make a positive, so that's a 63y squared. Good. Make sure to combine like terms. 56 minus 56 will cancel itself out. 3y squared. Oh, sorry. 32y squared plus 63y squared minus 40y. 32 plus 63 is 95y squared minus 40y y. So we have simplified it as much as we can. Oh, I'm sorry, you couldn't see that either. Blah. Okay. We distributed. Okay, last thing we're gonna do, that was subtracting, but it was also multiplying. Last thing we're gonna do is a couple of examples for multiplying polynomials. When you're multiplying polynomials, all you're doing is the distributive property, just like we distributed the minus signs or distributed that positive 8 and distributed that negative 7, okay? So for A, we take 3x plus 4 and we multiply it to the quantity x squared minus 2x plus 3. 3x times x squared, 3, there's no number to multiply it by, so it's just 3. X times x squared is x to the third, because we know the rule for exponents is x to the power of m times x to the power of n is x to the power of m plus n. So if our base is the same, we add the exponents, okay? The base is the same, we add the 2 and the 1, and we get a 3. 3x times a negative 2x. 3 times a negative 2 is a negative 6. 3 times a negative 2 is a negative 6. X times x is x squared, okay? Here, oh, sorry, I almost went to the 4. So what we've done is 3x times x squared. We've done 3x times negative 2x. Now, don't go on to the 4, Callie. Do the 3x times 3, okay? 3 times 3 is 9, so we're just multiplying the numbers, and then multiply the x's by the x's. There's 1 here, none here, so we're just going to have 1x, okay? Now, do those same 3 with the 4. Those same 3 terms, multiply them by the 4th, okay? 4 times x squared. 4 times x squared is just going to be 4x squared. 4 times the negative 2x. 4 times the negative 2 is a negative 8 with the x. 4 doesn't have any x's, so you're just keeping whatever x's you already have. X squared, x, no x. 4 times 3 now is 12. Good. If you have any like terms, you can combine them. 3x to the third minus 2x squared, because negative 6 and a positive 4 is a negative 2. Now we have a 9x and a negative 8x, so that's just going to simplify to x plus 12 for A, okay? B, we just have a monomial, 5x squared, and we're going to distribute it through the binomial 3x plus 4. Good. 5x squared times 3x. 5 times 3 is 15. X squared times x is x to the third. 5x squared times 4. 5 times 4 is 20. And then include that x squared of the 5x squared. Done. We cannot combine any of those terms. Okay, C. C, we have x plus 3 times x minus 2. So this is what we call foiling. F stands for first. X times x is x squared. O stands for outside. X times negative 2 is negative 2x. Inside, I in FOIL stands for inside. Inside is 3 times x. 3x. Last is L for FOIL. 3 times a negative 2 is a negative 6. Make sure you can't simplify. X squared. Negative 2x plus 3x is just a positive x minus 6. D asks us to distribute a negative x through x squared plus x minus 1. Negative x times x squared is x to the third. Negative x to the third. Negative x times x is a negative x squared, and then a negative x times a negative 1 is a positive x. That's all you can do. That is in its simplest form. And then I wanted to add 2 more examples. E and F. So letter E says 9 minus 4x times 9 plus 4x. Same thing, same foiling, okay? 9 times 9 for our first term. 9 times 9 becomes 81, right? 9 times a positive 4x for our second term. 9 times 4, 36 x, right? Now move on to your, oh, sorry, I was supposed to explain that better. 9 times 4. Your next term is your inside terms. Negative 4 x times 9. Negative 4 times 9 is again 36, but it's a negative 36. I did not include the x there. Last, I'll move it down here. Negative 4x times a positive 4x. Negative times a positive is a negative. X times x is x squared. Good. So this is 81 plus 36x minus 36x minus 16x squared. 81 minus 16x squared, because 36 and negative 36 cancel, or you could call it negative 16x squared plus 81. Good. And then this is the most important one, so thank you for staying all the way till the end, but this is going to show up on my math lab, so make sure you know what to do. The only new information is that when you have a binomial squared, it does not mean that you say 5x squared plus 2 squared. It doesn't even mean that you say 5 squared x squared plus 2 squared, okay? What you need to do is multiply all of this by itself. 5x plus 2 times 5x plus 2. So it's not a new skill, but it's just knowing that you need to write all of that out and do the FOIL instead of just saying 5x squared plus 2 squared. 5x times 5x is 25x squared. 5x times 2 is 10x. 2 times 5x is 10x. 2 times 2 is 4. 25x squared plus 20x plus 4, because if we had just said 5x squared plus 2 squared, right, that would have been 25x squared plus 4, and we would have lost that 20x. So make sure you write it out like this, not like this. All right, guys, that's all for today. Thanks so much, and see you next time.